We've been working on quadratic equations. We started with the unit when we were working with quadratic functions. By learning that the graph that it makes, that U-shaped thing, we called that a parabola. We learned that we had a parabola. We learned that the top or the bottommost, the lowest or the highest point was called the vertex. And we talked about all that vocabulary. Then we went through and we learned how to multiply binomials and polynomials like x plus 1 times 2x minus 4. We learned to multiply those. Then the unit we just finished was when we went through and we figured out how to take the product and put it into factors. Where we could factor by guess and check, we could factor by slide and divide, or many different ways when we went through and did that. Now what we have to do is tie everything we've done and pull it together to why do we do this? What is the reasoning? Where do we go from here? So one thing we need to review on, let's see if I can go backwards here, is let's look at this for a second. It says, which points are solutions for each function? Well, when it asks you for a solution, what does that mean? If it's an answer, like, how would I know if 0, 1 was a solution to this function? Well, it depends on if you have a graph or an equation. In this situation, we have an equation. So yes, you put it in the calculator. So right now, let's grab the calculator. Now, one thing I want to remind you of is f of x equals g of x equals, all of that means y equals. So this is the same as saying y equals. So we're going to go in the calculator, go to y equals, and put in there 4x plus 1. Now to figure out if 0, 1 is a solution, I can go second graph and go into my table. And I need to look and see, is 0, 1 in my table? Sure is. That would mean that that's a solution to this one. Then it has in there like -5, -19. Is that what's here? No. Look right here. We have it in there when you press second graph. -5 and -19 is there. That one would be a solution. Well, another one they have listed is -2, -7. Yes. All right. Well, geez, all of these are. Let's see here. Let me move this up. Now, what about this, the one that says 3.5? Let's remember, I don't see 3.5 anywhere on here. I don't see any decimals. So we need to remember how to do that. Go to second window, which is your table set. Let's put in there our x number, 3.5. And then press second graph. Now, is 3.5 and 15 in there? Yes, it is. Now, wait a minute. Here's the thing, though. Like, I need to go back to -6. And so what you'll do is go back to second window. Let's type in there -6, second graph. Is -6, -1 in there? No. Okay, so remember how to put that back in the calculator, that you're writing, that you're clicking on second window and changing your x numbers to find your values. We would do the exact same thing for this one here, right? Because g of x is the same as y equals, but I'm not going to go through that one right now. I want us to just move along to this graph. If we had the graph, I would go over here to the graph, and like, for example, if I want to check 0, 1, 0, 1 is right here. Is that dot on this line? No. So that would not be a solution. What about -2, -7? -2 down -6, -7 sure is. That one's on that line. Whoops, don't lose it. There we go. Let's see. What about -6, -1? -6, -1. That one is. 0, negative 10. Yep, it's down there. Let's see if I can find another one that's not on there. But negative 5, negative 19. Negative 5, negative 19. That one's not. Now, 3.5 and 15. What if I go over here to 3.5 and up to 15? No, that's way up there. That's not. These three would be. All right. Now, let's look at the paper that you have. Oh, let's go here. Let's see here. All right. Let's look at this paper right here. And it has a graph and a table for you. So I want you to go into your handy dandy calculator. Put in there 2x squared minus 8x minus 10. I want you to press second graph and fill in the table that it gives you on your paper that you have in front of you. I want you to fill in the table and then graph those points. Please do that now. All right, so on your table, here's what you should have gotten for your table and your graph. Now, the questions that you have below on here, it says, which on my screen is, where'd it go? What's that? It's right here. But instead of me going back and forth right now, I'm going to start, well, we'll do this. I'll do it this way. I'll go through and we'll start with number 1 and I'll flip back and forth. All right, the first question says, place your pencil on the graph that represents all the points with a y-coordinate of 14. What is the equation of the horizontal line represented by your pencil? So here's what it's saying. It wants us to go over here. I think this is going to be my problem, is it that I'm going to keep doing this. All right. It says wherever y equals 14. So let's draw our line, and that's going to go across right here. Y equals 14. This equation right here, all these points are y equals 14. The equation of a horizontal line is y equals 14. If all those numbers are 14, that's what it means. So it asked you to draw a line, and I want you to label it y equals 14. The next question says, find all the points where your pencil intersects the graph of the function. Okay, so right here, it wants us to circle these points right here where our function intersects that line. And on our table, let's circle where the y's are 14. Now, right here, okay, says find the points where they intersect on your graph. Highlight these points and intersections on your graph and on your table. So right now, this is all we're doing. What this is saying right here is that instead of having y right here, if I took my equation and set it equal to 14, we would be looking to see where my parabola, where my y numbers are at 14. So if this was the question, we would be looking to see where y was 14, finding out what is our x numbers. We're going to get more into that in just a second. So now one of the next questions says, what are the x coordinates that you highlighted? All right, so my x coordinates are -2 and 6 because see, look, I've got -2, 14 and 6, 14. So on your paper right here, the x coordinates, we're going to write x equals -2. What was it? -2 and 6? Okay. -2 and 6. Now this time it's saying Slide your pencil so that it models the equation y equals negative 10. So what we're going to do now is, it's asking us to go to where y is negative 10. Okay, so let's go down here, find where y is negative 10, and I'm going to draw a horizontal line to go across. Let's see here. There we go. Where y is negative 10. Okay, I'm going to circle those points on my graph where y is negative 10. And I'll circle or highlight those points on my graph right here. So what this one is doing, it's giving us this function, and it's saying if y right here, if it said negative 10 equals, and it has this quadratic, that means we're looking to see where y is negative 10. That's what it's asking us to do on this graph. So for our answers, let's go back here. What was I supposed to have? My x numbers are 0 and 4 because it's crossing where x is 0 and x is 4. So on our answers right here, we're going to have x is 0 and x is 4. Now look at this one. This one says slide your pencil to find the x values when 2x squared minus 8x minus 10 equals 0. This time it's telling us where y equals 0. So underline that equals 0. Write out to the side y equals 0. Now we're going to go back here, and I'm going to erase all my stuff on mine just because it's easier. You guys obviously need to keep it on yours. Let's see if I can get all this erased maybe. Okay. Oh, golly, what just happened? Okay, so now it said make this where this right here is where the y is 0. Well, if I draw my line where y is 0, that's going across right here. Now that line is actually a very special line. This is y equals 0 on my equation, just like this one up here is y equals 14. Down here was y equals negative 10. But y equals 0 has a special name. What is that line? The what axis? That is the x-axis. See, y equals 0 is the x-axis. These points where it crosses right here, where y is 0, are very important points. They are our x-intercepts. It's where they cross the x-axis. But here's the other thing. You guys need to have written down that another name for this are the roots. We also call them the zeros. That is only true when y is 0. So let's see, I have negative 1 and 5. So let me go back over here for a second. So right here I have negative 1, oops, and 5. These points right here are called, that's what I wrote on the other thing, they were your x-intercepts. We called them your roots. We call them zeros. In this case, it's the solution because that's where it equals 0 when it's setting it equal to 0. Now the next one asks you, let's slide our pencil to where y is negative 18. So if I go back over here to where y is negative 18, what do we notice? Down here where y is negative 18, oh, I heard it. This point, what is this point called? The what? It's the vertex. Is this a minimum or a maximum? It's a minimum. when they ask me for my solutions where y equals negative 18, do I have one or two? Because all these other ones, we had two solutions. Am I going to have two? No, I'm only going to have one because it only touches that line one time, right? That's because it's the vertex. So right here, it should be, you guys need to tell me real quick because I moved my, what was this where y was negative 18? What was that x number? X equals 2. Why is it different? Because it is the vertex. Now, it says what were the x-intercepts? We already found those up here. They were negative 1, 0, and 5, 0. Oh, golly gee willikers. Let's see here. Okay, now look at all this down here. What the heck does this mean? I don't think anything we're doing right now is real hard, but you have to know how to read this stuff mathematically. First off, this says f of 2 equals, and it gives you a blank. Then it says f of 4 equals, and it gives you a blank. Then it said f of x equals 14. How about I write a 14? There we go, and a blank. Here's our function. What does it mean when it says f of 2? 2 is in the place of what? The x. This is saying when x is 2, what is y? So look on your table. Let me go backwards here. I'll go right here. When x is 2, what is y? Negative 18. So it wants you to write down here, negative 18. Now when it asks you again right here, f of 4, that's saying when x is 4, what is y? So we look back over here. When x is 4, here it is. What was the y number? Negative 10. Oh, let's see here. All right, now how is this one different? We're trying to find the x number on this one. Because remember I told you that f of x equals is the same as y equals? This is saying y equals 14. So when y is 14, what is your x number? Now wait, you guys are giving me two different numbers. What's happening here? It's negative 2 and it is 6. Because at 14, remember they cross at two spots. You do not add them. They just ask you where the y was, and you would write x equals 2. What was it, negative 2? Negative 2 and x equals positive 6. You're going to have two answers a lot of times on your parabolas. Now we're going to go into, flip your paper over for a second. On the blank part, I want you to write this down. X-intercepts. When you have x-intercepts, they're asking you for the roots and for the zeros. Please have that written down. Now the next thing to this is that you will have three types. You could have three types of solutions. You could have one solution, one root, two solutions, or no. I'm going to write solutions instead of roots. Oh, let me not try and move that. Let's write solutions. Okay, let's get that written down and then we can go on in just a second. All right, so now when we are looking at our other problems on the other side of that paper, we should have had the graph done and the table filled in. If you don't have that done already, please do that now. All right, now looking at this, the next questions we have, it says place your pencil on the graph to represent all the points with a y coordinate of 0. Ready? So on our graph, we're going to go where y is 0, and I'm going to draw a line. Oop, I need a color here. Nice line. There we go. This is y equals 0. Guys, y equals 0 is the x-axis. Okay? Now, it says find the points where your pencil intersects the graph of the function. Highlight these points of intersection on your graph and on your table. So they intersect here and here. It's where y is 0, and so I'm going to circle these. Those are your x-intercepts. We also call them roots. We call them zeros. You're going to have to know those because I'll ask you those by name. So then it says on number 13 on your paper, it says, what are the x coordinates of the points you highlighted? X equals 1.5. X equals 2.5. Number 14 now on your paper says, slide your pencil so that it models the equation f of x equals, -3. Guys, that means y equals -3. We're going to go to that line of y equals -3 right here, and you're going to draw a horizontal line. Y equals -3. Now, what it's saying is if I have this equation up here and it says -3 equals, and then it gives me -4x squared plus 16x minus 15. You're trying to find your x numbers when y is -3. So I'm looking here and here. These would be my answers where y is -3. So now my x numbers, which this is still problem 14, you would write x equals 1, x equals 3. Okay, we should have those down. Then it says on number 15. Number 15 says, well, let me go back over here. Let's look at this. 15 right here. Slide your pencil to find the x values when -4x squared plus 16x minus 15 equals -8. That means look and see where y equals -8. So now you're going to go back over to your graph, and you're going to go to where y equals -8, and we're going to draw our line. We also can find it in our tables right here. X equals 0.5, x equals 3.5. On those dots right there. Now notice, each time we've done this, how many solutions do we have? We have 2 each time because it crosses twice. Look at this next one. Let me erase all this. All right. This next one says, number 16 says, slide your pencil to the x values when this function equals 1. So it's right here, it says 1. So when I go to y equals 1, I'm going to go across here. How many times does it touch my parabola? Once. It only crosses once at 1. That's because that point is your vertex. Your answer is x equals 2. This only has one solution. Now, number 17. 17 says, what are the coordinates of your x-intercepts? Your x-intercepts are right here, where they cross your x-axis. Okay, so that is 1.50 and 2.50. These are your roots, your x-intercepts. This is on number 17, yes. So now, when I look at all this, number 18 says, problem number 18 says, what is f of 1.5? It says, what is f of 2.5? Then it says, f of x equals 0. What are my answers to this? What does this mean when it says f of 1.5? I'm looking to see where my x or my y, which? Where my x is 1.5. So right here, f of 1.5 is 0. That's where my y number is 0. F of 2.5 is 0. Then it says, what about when f of x equals 0? They want to know what your x numbers are, which is 1.5 and 2.5. Number 19 says, what do you notice about the x-intercepts and the solutions you came up with for f of 1.5 and f of 2.5? They are the same. The biggest thing tying all of this together is this. It says down here in your own words, what is the relationship between the x-intercepts and setting your equations to 0? The relationship means it is the same thing. When you go to find x-intercepts, you're looking to see where they cross the x-axis. When you're setting an equation equal to 0, you're looking for the x-intercepts. It means the exact same thing. Now, look at the back. On the back, it says for problems 21 through 23, refer to function A. It says on 21, you are asked to find the x-coordinate where the value of the function is 14. How could this be written mathematically as an equation? Okay? It says right here where the value of the function is 14. Underline that right now and put y equals 14. What it wants you to do is take this equation. How do you write it so that you have y equal 14? You just put 14 in the y spot. And when they give you this function and they say where y is 14, what you are looking for is this right here. You're trying to find the x numbers that satisfy that. So when you look at number 22, it says, how does the quadratic function compare with the equation you just wrote? The quadratic function is just this. And all it's saying is that we take that and we set it equal to 14, to whatever number we're trying to look for. Number 23 is exactly what we were doing on the other side. It says, for which x values does a function have a value of 20? So it wants to know, let's see if I have, oh geez, let's see, let's go back here. So it wants to know right here, for which x values does a function have a value of negative 20? That means where is y negative 20? You should have that table written down there on that problem. Now if you go up here to where y is negative 20, does my parabola touch that line? No. And that's what I meant by saying this has no solution. On that graph a little bit ago, there was 3 types of solutions. 1 solution, 2 solutions, and 3 solutions. So now at 24, it says if, I think if I go back here, let's see if I go back. Nope, I gotta go forward. 24 says, for function b, you are asked to find the x-coordinate where the value of the function was 0. How could it be written mathematically? Well, if the function equals 0, that's y equals 0. You would write this right here. 0 equals, this needs to be written down on your paper. Okay, so what I've just tried to say is that you have 0 equals negative 4x squared plus 16x minus 15. Or you could write it with the 0 at the back. It doesn't matter which. Whoops. No, well, just a second. When it says how do they compare because you're, how are they saying? Well, they're the same equations. The difference, oh golly, why do I keep going the wrong way? There we go. They're the same equations. Like you have the equation, but all we're doing when they say when the function equals 0 is we're setting it equal to 0. Now, what if it says on here, what if I asked you, what is the solution? Oops, let's see. This is not on your paper, but what is the solution when f of x equals negative 8? What would you do? You would go to where y is negative 8. You could look at the graph here and you would see your answer here and here. Or you would look on your table where y was negative 8. Your answer would be your x numbers. X equals 0.5. X equals 3.5. There's always 2 answers if it crosses twice. It could be just 1. In conclusion, when you have a graph or a table and an equation, how do you determine what the solutions will be? You determine the solutions by what the equation is set equal to. Meaning, if it says it equals negative 18, you look and see where y equals negative 18. If it says you have this whole equation and it says it equals 4, you look and see where y equals 4 and you find your x numbers. See, the whole idea is right here, without using a specific function, explain the difference between f of x equals 3 and f of 3 equals y. See, f of x equals 3. That's saying y equals 3. So if I had to write it in a table, they're giving me the y number. I'm trying to find the x. If it says f of 3 equals y, they're giving me the x number. So they're giving me the x number, and I'm trying to find the y. Okay, so on here, it says compare the graphs of the same quadratic function. So right here, I've got an equation. It says y equals, x squared minus 5x minus 6. And this one says negative 6 equals. The only thing different is this says negative 6 and that says y. The solutions to the ones over here, the one where it says y equals, every point on this parabola is a solution. It doesn't tell me any specific ones. Now, on the one on the right, it limits the points to those that are only where y equals negative 6. So my solutions to the one on the right are only 0, let's see, and 5. I was trying to look and see so we could show it more. But when they ask for solutions, if they don't give you a specific number, that means it's all of them. So then right here it says, how is f of x equals 2 and f of 2 equal y different? Well, f of x equals 2 means y equals 2. Y equals 2, when I come across here, y equals 2 at 2 spots, here and here. So f of x equals 2. My answer is x equals negative 2 and x equals 3.5. But when it says f of 2 equals y, that's saying where x equals 2. X equals 2 is right here at this point. So my y number is negative 10. So in the summary, it says, what are the solutions when f of x equals negative 10? F of x is the same as y equals negative 10. So as I go and look for where y equals negative 10, I'm going to go across here in my nice straight line, haha, and it crosses in 2 spots. It's my solutions are x equals 1. See, it crosses right here at 1. And at 4, x equals 4. Now, when it says when f of 3, then f of x equals, well, this is saying when x equals 3. X equals 3, let me erase these other lines. When x equals 3, I come over here and I'll go down. It's this point right here. So my y number is 12. I'm sorry, negative 12. Then it even says fill in the blanks. The y number is 8. So when you look for the y number of 8, it crosses in 2 spots. So I would have negative 2 and 7.